We're going to continue on the theme of amazing young people, our leaders, not just of the future, but our leaders today. You may have seen these two women TED Talk or read about them in Fast Company magazine. They are the co-founders and CEOs of BioSelection. They're going to tell you all about it. Please welcome Miranda Wang and Jeannie Yao. Welcome.
Everyone wants to get rid of plastic pollution, but few actually want to pay for it. And this is not because we don't care or we don't understand the problem, but it's because so far it's been extremely difficult to build a compelling business around the solutions. Our current plastic loop is broken. And every year we produce 300 million tons of plastic products. After that product is consumed and disposed of, a lot of it is collected and sent to recovery or recycling. But only less than 10% of these lucky plastic products are actually being recycled, and the rest ends up in landfills, incinerators, and the oceans. So why is it that we are so bad at recycling more plastics when we have the technology? Well, the problem really lies in the material that plastics, the chemical structure themselves. It's very difficult for us to sort and clean plastics very economically, and it's further more expensive to hire human labor as well as buy efficient technology to even do the recycling. The products that we actually make from this recycling process is always a lower grade polymer that competes with fossil fuel derived virgin polymers. So there's really very little economic incentive. It's very hard to make money in this business. And when we look at other plastics like film plastics and polystyrene, which are the major problems, these plastics are not even recyclable once they're contaminated. And the overall systematic solution that we use right now is to directly dump all the residue material that's left over from a plastic recycling process, which can be up to 80% by volume of all total waste brought to these MRFs, or material recovery facilities. We just dump them into landfills and incinerators. And sometimes 4%, which is the stat right now, of these plastics, overall plastics, actually end up in the oceans and become ocean plastics. So if you look at this problem here, it's really saying that our materials recovery system is broken, because right now it's very expensive for us to recycle at all. And moving forward from here, the problem is not something we can directly solve just by directly banning plastics, when green plastic polymers are not something that we can easily adopt right now. And also, this solution we have for increasing efficiency recycling is good, but it's still not going to be good enough to solve the problem of existing plastic pollution. But in the end, all the problems we have because of plastics in the environment is really caused by the fact that this material is so inert that, unlike most organic materials on our planet, it just simply doesn't biodegrade. It takes 500 to 1,000 years for plastic polymers to actually become something as part of nature again. And most of this time that this material exists is just disintegrating into smaller and smaller pieces of microplastics, which adds another layer of complexity to this overall problem. So why don't we take this plastic and actually break it down? And in this process, try to make this a very valuable process that actually makes economic sense. So the solution we're going to propose involves, first of all, increasing the efficiency of recycling, because I do believe in that. And I believe that by increasing the amount of materials we recover, we can actually do a very good job of closing the currently existing loop. But that's not going to be enough, because there's always going to be residue material that's left over from this recycling process. And that material is still ending up in incinerators, landfills, and oceans if we don't deal with it. So why don't we take another approach at looking at how to close this loop? Because why don't we look at ways to actually upcycle this material, real upcycling, not upcycling that turns plastic to plastic or plastic to something that competes with oil, but turning it into something that actually is really increasing value, real upcycling. And by definition, I mean that by destroying the plastic polymers on a molecular level and turning that into a valuable product that can actually be sold outside of the plastic loop. And this technology will provide the ability for us to deal with ocean plastic retrieved, because right now, most of that plastic is retrieved has no market or nowhere to go right now. A lot of that plastic is sent to companies to make new kinds of clothing for enhanced PR value. But most of it, up to 80% of the material collected from beaches, is actually not recyclable. So this also gives the existing plastic pollution that's retrieved a channel for the downstream. It also gets rid of plastics that are currently in the landfill. So this could be an approach, upcycling could be an approach for us to clean up existing landfills.
Ever since Miranda and I were in high school, we've been involved in sustainable initiatives. The environment club that we managed used bottle recycling deposits to fund cool projects such as our first school garden. When we were 17, a field trip took us to a MRF in Vancouver, where we saw with our own eyes the scale of the plastic pollution problem. So we had an epiphany, and we started researching into ways to break down plastics using bacteria. Then for the next 5 years, we worked on this research while studying at UPenn, McGill, and the University of Toronto. But gradually, we realized that bacteria simply cannot break down plastics at an industrially scalable rate, because polymers are too large and too inaccessible for bacteria to directly use as a food source. The best result anyone has ever achieved was to use bacteria to break down a small piece of PET film in 6 weeks. The other problem is that this process only generates carbon dioxide and water and no valuable products, which also renders this approach economically unfeasible. So when we were 21 years old, once again, we had an epiphany. We were accelerating our biotech startup, BioSelection, in inventing a truly satisfying solution to the plastic problem. And in that process, we thought, what if we just helped our bacteria a little bit by using chemistry? You see, if we can break these polymer carbon-carbon bonds by recreating the enzymatic reactions using chemistry, then we could save a whole lot of time and generate readily digestible food stock for bacteria. So we went on to build a series of chemical reactions to turn mixed plastics, including film and foam, into carbon salts in a continuous process. Now, these salts, although they're derived from petroleum products like plastics, they are nowhere near petroleum monomers chemical-wise. They're actually more similar to sugars. And when we feed these salts to engineered bacteria that have been adapted to use it as a carbon source, they can replace sugar in an industrial biotech process, yielding high-value compounds worth hundreds of dollars per kilogram. For instance, there are biosurfactants detergents that can be used in textiles manufacturing. Other examples include additives, enzymes, and antimicrobials usable in the pharmaceutical and cosmetics industries. In this integrated technical approach, we're transforming plastics that cannot be dealt with current technology into food stocks for entire microbial factories that can produce valuable bioproducts. So a recent trip back to these MRFs actually validated the value propositions of this technology and helped us envision how we're going to integrate it effectively. Here's a closer look at the residue materials generated from these MRFs that are heading to the landfills. You can see that visibly 80% of it is plastic films. It's also mixed with other types of plastics, debris, organics, and paper. We can get rid of this plastic, and this is how it will look. Imagine you're standing in a part of the MRF where this residue material is aggregated. So the bulldozer that originally will load the waste material into a truck that heads for the landfill will instead load the same waste residue materials into a machine. And our technology is being developed into this on-site machine that can handle all sorts of plastics. Using physical chemical processes, the plastics components will be decomposed and chemically modified into these sugar-like microbial feedstocks, whereas the other miscellaneous residues will exit the machine in a much smaller volume. And this machine will be automated to save workers' time and can be added on to currently existing MRF units at a low switching cost because it does not replace or change any of the current processes. It captures energy from this waste residues and uses very little external energy to make it a sustainable process in the long run. And it does not produce any toxic intermediates, whereas the end products occupy less space and are easier for transportation. So in the end, this process as a whole will decrease transportation costs as well as landfill tipping fees.
Yeah, so the value that we offer in general is using this technology, we think we can cut the cost of MRFs in reducing the amount of residue they actually need to send to landfills. This technology will also be able to deal with current existent plastics and give it a place to go. And in addition to that, it's actually providing a real economic solution because we can, for example, let out these machines on subscription models, and MRFs will be able to cut down their costs from reducing overall residue volume, as well as benefit from the potential revenues generated on the other end from these microbial feedstocks. And these can be sold first to chemical companies, and later BioSelection can use it to fuel the new materials biosynthesis stream of our business. But really, this can be something used around the world and can be a new way that we fuel industrial biotechnology. Right now, we're ready. We're going to be ready to launch our pilot project in Q3 2017, and there's at least one municipal government in the Bay Area that is interested in working with us. So we're interested in hearing your thoughts about this overall idea, as well as finding partners who are willing to work with us in this space. We believe that right now the plastic loop is really hard for us to close because we're missing real upcycling. And if we just think beyond plastics and beyond the current way we're considering this loop, we'll be able to find the solution. Thank you.
Thank you so much.